Hello, everybody. My name's Brent Thorne, and I'm a graduate student at Brock University in Ontario, Canada. My research focuses on the hydrology of Arctic wetland lakes and ecosystems. And today I'd like to talk about my experiences in graduate school using R and R Markdown. So I fell in love with R when I realized I could create GIS and remote sensing products for free as compared to the proprietary and kind of expensive software. And that kind of led me down the path of wanting to do as much as I could in R as possible to streamline my workflow. So what I'd like to do today is just talk about how I took kind of my passion for R Markdown, turned it into thesis templates and other templates as well, and just also quickly touch on why it's important to introduce others to it and how to go about that. So I often get asked what packages that I use to write my thesis. I've made a list here. The one that I'll highlight is, if you look at conference posters, you can see Poster Down. I'm biased towards that because that's the one that I made. And I made it mostly because I wanted to be able to take my already written R Markdown document, which was vanilla Markdown formatted, and just produce a poster without having to change any kind of syntax whatsoever. So I made the Poster Down package, and I learned quite a bit from making that package, including how to share what I've done with my colleagues. I quickly became the person that wanted to tell everyone about how to use R for everything. And something I've learned from that is when you're trying to share with your colleagues or your coworkers, it's important to, when you introduce, it's very good to show versus tell. So I relate that to the first time you generate a plot with base R or something, but it's similar as in seeing that final knit document is a really good experience to show new people. Next, when you're introducing people to R Markdown, I found myself getting caught up in the decision of should this use case be for HTML or LaTeX or LaTeX or even Word. And to be honest, at the beginning it didn't really matter, and the focus should be more on just getting the person up and running and learning Markdown in general, which includes maybe helping them install R for the first time if they need that. This is what I spent most of my time doing in my lab. So the next part, I just wanted to talk quickly to the people who create templates or packages themselves for R Markdown. I kind of want to challenge everyone to see if we can simplify the syntaxing to make sure that if someone writes a document for one template, they can just take that document and render it in a different template as easily and efficiently as possible. That was kind of the goal of Poster Down and why I ended up making it, because I didn't really see any other options that kind of allowed for a quick transition from a long form written document to something like a poster. So for thesis supervisors or supervisors in general, I mean, most of us know these benefits, but these are I find the good talking points when you're trying to convince, if you're the graduate student talking to a supervisor about why you should start using R Markdown and Git. So we talk about version control, reproducibility, and I think the big one is emphasizing once you get it set up and running, you're going to have more time to focus on the important stuff, such as making more manuscripts, right? The final one actually that I really like is the no need for tracking down students to see how they did some analysis or came up with results, because you have it all documented. So overall, those are the talking points that I have. I really enjoy if anyone wants to come and chat further about this. This is something that I'm definitely interested in. And I'd also just like to thank useR for providing the opportunity for me to come to this conference today. So thank you to everybody.
jump in, get an extra 20 seconds. Good morning, everyone. My name is Paul Stevenson. I'm a biostatistician at the Thorne Kids Institute in Perth, Western Australia. So we are a children's medical research institute that's co-located with the Perth Children's Hospital in the brand new building that opened up about a year ago. So this gives us a really unique opportunity to work with our researchers at Thorne Kids, but also research active clinicians within the hospital. So it's often the case that larger research groups are able to employ their own biostatistician. However, it's very cost prohibitive for most research groups, and especially for research active clinicians within the hospital. So our team within the Institute, at the Biometrics Group, we offer low barrier initial free consultations for data analysis, biostatistics, data management and database development on a per project basis. This option is very attractive to the local health research community as it makes our biostatistical expertise affordable and easily accessible. But because of this, our group works on a multitude of projects simultaneously, and each individual is often working on several projects at once. So the motivation for this talk is the template project and the template workflow that we set up to help streamline project initiation and being able to jump in between projects and being able to pick up where we or someone else left off. So we make sure we incorporate the principles of reproducible research. So we are dealing with people's medical data, and the findings that we find in our analysis will lead to translation into health practices. So we want to make sure our research is traceable and verifiable. We also report our findings with our collaborators with really nice HTML documents, which I'll go through a bit later. So here's a representation of our project template. So this is a network graph analysis. I just thought it was a bit prettier than taking a screenshot of Windows Explorer. So each of the squares in this graphic represent directories within the project, and the circles individual files. So we have folders for data. I've actually got 3 folders for data, and I'll briefly go through those later. I've got some admin directories which deal with the stuff about the project but not related to the actual analysis. Some reporting directories and some directories for our scripts to run in. So we use the project template package. We find that this is really attractive because it allows us to automate several aspects of the project, including project creation, which is super simple with that one liner at the bottom there. And we can also automate the importing of our data, either raw data or cache data. If our data changes, we can execute manuscripts automatically. And then at the end of that process, we do our analysis and then we report. And we use Markdown to do our reporting, and I'm sure you're all very familiar with Markdown. We love it because it allows us to automate our tables, figures, models, analysis and commentary in a single document. And we can also cross-reference super easily with various packages. And it also eliminates the need for me to transcribe numbers from tables into text, which I'm horrendous at doing. So it's also really good because when the underlying data changes, you just re-knit the document and you've got an updated document that you can send to your collaborators that doesn't need much extra work. So this is an example of the Markdown template that we use. So it's a HTML document, and it's built on Bootstrap, so it has all the modern features of modern web pages. And it's really easy to scroll through and navigate and find findings. So we use a number of packages in our toolbox that help us focus on doing the actual analysis and not thinking about how we can do these other little things for our reporting. So we use Captioner to cross-reference, Cable Extra for all our tables, Tidy in the Broom package to make our model estimates look nicer, RepMiz to make a bibliography of the packages that we use in the analysis, Plot Sums, which is a great visualization tool for comparing various models and the estimates of the models, and ggpairs for doing plot matrix that helps us with our initial scoping of the data. So this approach has allowed us to streamline our workflow to expeditiously initiate projects and produce professional-looking reports in multiple formats directly from our analysis package without wasting time on the non-analytical aspects of our projects. So that went super quick. So I'd like to thank the organising committee for inviting me to give this presentation. the biostatisticians in our research, in our work group for their input, and the people and culture team at work for funding my trip over here to spend time with you lovely people. Thank you.
Hi, I'm Ildiko Czeller. I'm a data scientist at Immersis for 4 years now, and I'm also a security enthusiast by night. And I'm going to present you the RAPSEC package, which is to help you with operation security. It started as an R Open Science Unconference project last year, and it is already available on GitHub. The main motivation to develop is to promote best practices, because in my opinion, security is really important, but it's kind of unnecessarily hard to do. So this package aims both our users and our developers, and it provides functions to identify issues and also steps to improve your security. So one layer of security is verifying the authenticity of your commits. So what it is about? So it is about about who you are. It's not to be mixed with authorization, which is about what permissions do you have, but not about your identity. So here's an example that without signing commits, you can commit in any name you want, and it also means that others can commit in your name as well. If you turn on commit signing and verifying authenticity, you can still commit in any name you want, but now GitHub will show that your commit is verified or it is unverified. It becomes useful if the repository admin configures that only verified commits are accepted to the repository, so no one can commit with a different name or address. So why is this relevant? It becomes relevant maybe in a bigger community or company where it's important that people cannot do unwanted things without leaving a trace. It also adds an additional layer of security, because it is much easier to just steal your credentials than to steal your credentials and your key to sign commits. So how does this work behind the scenes? First, you have to generate a private and public key pair on your computer. The public key you will share with everyone. And for example, GitHub can verify on a different channel that the public key is connected to your virtual identity. Then if you sign commits with your private key, then GitHub or anyone in the possession of your public key can verify that the commit comes from you and not from anyone else with just writing your name. It is secure because without your private key, you cannot provide a valid signature. So what is the specific technology for this general concept? OpenPGP is a worldwide standard, and GPG implements low-level functions for it, and the RAPSEC package adds functions for end-to-end use cases. One added value of the RAPSEC package is reducing the risk of user mistake, and it is achieved by asking for user confirmation before critical steps, like overwriting your Git email configuration. You don't want to do that by mistake. Another added value is to communicate the status in detail. It is important because it guides the user what the next step should be. For example, there can be a number of reasons why uploading your public key to GitHub was unsuccessful, and the next step should depend on the reason. An interesting aspect of the RAPSEC package is that most of the code either interacts with the user or changes settings outside the scope of your R project, and thus it is not straightforward to test. For example, how do you test changing your Git configuration without actually changing your Git configuration? I chose to test with so-called stubbing from the mockery package. It works like this. So first you have to define what function you don't want to be called, and you also define a simulated return value, and then you can proceed with testing as you would do otherwise. Another function that the RAPSEC package provides is a list of suggestions as how to improve your security. For example, what lengths of your key should be for secure shell connection. So in these few minutes, I introduced you the Rucksack package, which is already available on GitHub. Its two main functionalities are signing your commits and auditing your computer. I encourage you to try it out and report any issues you find. Thank you for your attention.
Hello, so I'm Nikki. As you can tell by my name, I'm Italian, but I live in Zurich, and I am a consultant in Zurich for a company called Mirai Solutions. And today I'm going to present Compare With, which is a user-friendly diff tool that is also used for version control system interactions. And the company that I work for is, again, Mirai Solutions, and we are very much R enthusiasts. So we'll be happy to answer any questions later on, and if you have any other changes to suggest. So the issue that we started off with was that version control tools in R and RStudio are not as developed as much as we would like them to be. And then particularly now with the uprise of Git and GitHub, then we have more people contributing to the same branch, so to the same project. So for example, you have a master branch, and then people can create sub-branches, do their commits and pushes, and then they merge back into master. But then this can create a lot of conflicts, and the code is not very homogeneous. In fact, it's very heterogeneous. So for this reason, we created Compare With that allows users to interact with Meld directly from RStudio. And Meld is a diff viewing tool. And this package provides different add-ins that can allow you to compare the same file with the repository version, or two different files, or edit file directly in the Meld view, and particularly merge and resolve conflicts. And that's the URL to our GitHub repository, so feel free to go and check it out. And I will also explain later how to install it directly from GitHub. But now going into more the practical view of what this means, say I've edited a file on the top, and then I save the changes, I install Compare With, I can click in the top right on the add-ins menu, and I have the list of the add-ins that I can use at the bottom there. In this case, I want to compare with the repository version, so I can click on Compare With Repo, and then I have this view that shows up. And this is the Meld view. So in this case, on the top, you can see that I've edited a line, and at the bottom, I've added another line, so they will have a different color code. In this case, for example, if I want to undo a change, I can click on the X. In this other case, instead, I pulled, and I have a conflict. The conflict will show in red. So in this case, I have the conflict between the remote version and the local version of the same file. And then in the middle, I have the merged version of the two. So in this case, if I want to have the changes that I've done in the remote version, I click on the right, and then I have the changes in the merged version, which will show in blue because it's not a conflict anymore. So then I can save the file, close the window, and then Meld will show this other pop-up window at the bottom that says Mark Resolved or Cancel. If I click on Mark Resolved, then the conflict will be solved. And this will also show in the RStudio panel where you have the Git view. Then if you have a conflict, it has an orange U. In this case, it will show a blue M as if the file was just modified. So in this case, I use the add-ins, but I can also use command line functions. So in this case, if I want to do the same action that I did before to compare with the repository version, I can type Compare With Repo, and then I need to specify the path to the file. If I want to compare two distinct files, then I also need to specify the location of the other file. You can find more information on the README that we have on GitHub, and also about the installation of the package, which has to be done with the remote package because as of right now, it's not on CRAN yet. So you can just type the line over there, and it's gone, and then we'll install the package. So just to conclude, Compare With is a diff tool that allows users to interact with Meld directly from RStudio, and you can do several actions, including compare files, edit files, and merge and resolve conflicts. We also added other features, including throwing an error if the Meld version is not working properly, or if you have not installed Meld at all, which has to be done separately from the package. And also, if you, for example, use the command line functions, then if you have not specified the right path or the right location. Other than that, this is the URL to our GitHub repository. We also have other open source projects that you're welcome to go and check out. And we look forward to your feedback. And also after this session, I'll be happy to answer to any other questions that you guys may have. But thank you in the meantime.
Hello, everyone. I'm Hannah Frick from Mango Solutions, and I'm talking about the Good Practice package, which is a tool for package development. And I'm glad I got that in, because I don't have a title slide. So if you are not a package developer, I would like to encourage you to become one. So all these functions and scripts that you've got lying around, put them in a package. I promise you it'll be easier to install and load and share, and when you then start adding more functionality to version it. If you are going to go on that endeavor and make one, you probably want to make it a good one. In my eyes, that is, first of all, that it's installable, because duh, that it is bug-free, at least as possible, as bug-free as possible, sorry, that it's easily maintainable, so be kind to your future self, and all that isn't anything revolutionary. Our community has spent considerable effort already on making tools to make this as smooth as possible. So our command check doesn't only check that it's installable, but a whole bunch of other things, and is the standard for getting your package on CRAN. Tests are the go-to tool to make your code as bug-free as possible. The test app package provides a framework for unit tests. The cover package calculates test coverage. That's the measure of how much of your code is actually run when you run your tests. And one idea to keep to make your code more easily maintainable is to keep your functions simple. So the cyclocom package calculates code complexity, or cyclomatic complexity, which is a measure for code complexity, and keeping your code easily readable by adhering to a consistent style also helps, and the linter package does that for you. So the Good Practice package was originally written by Garbor Chardy during his time at Mango. I think it's great work. That's why I'm the maintainer now and stand here and talk about it. It performs static code analysis on your package source code, combines the aforementioned tools to carry out 230 checks, gives you advice on what to do and not to do, and tries to combine that with a short reason why, and also where in your code that is happening. So having all of that in one place makes it easier to use and also harder to forget anything. And if you work in a team, you can sit down and establish your standards beforehand and then use Good Practice to help hold everyone to those standards. So if you want to use it, you just need the GP function from the package, feed it the path to the source code, the raw version, not the packaged one, and you get an output like this, telling you that your test coverage is 53%, so that could be improved. It tells you that, for example, in the node.r file, the following lines are still untested. It reminds you to add a bug reports field to the description so that people know how to let you know what you still need to fix. If you happen to use the capital T and F for the logicals true and false, it will tell you that those are actually just variables that could be overwritten, and it is safer to just use the logicals if you mean the logicals. And when you get your package to state that it passes all of these checks, you get praise for your great work, randomized by the praise package so that it doesn't get boring. If you save the return object, you can do a little more than just print with it. Maybe the most straightforward ones is that you can check which checks you carried out, which ones failed, which ones passed, get that in the data frame. Obviously, that's more interesting if you run this on several packages rather than use it during interactive development of one. While I think that all of these checks are rooted in sensible ideas, I'm aware that you will all have opinions and use cases of your own, so you can customize Good Practice by only picking the checks that you want and ignoring the others, and by adding your own ones. So Good Practice comes with two functions, make check and make prep, and there's a vignette with detailed examples and explaining how to use those two functions in the custom checks vignette. Link for that is to come on the last slide. And if you want to see an example in the flesh, take a look at the checkers package, which is also our OpenSci output. So to quickly wrap this up, the Good Practice package performs static code analysis on the source code, gives you advice on what to do, not to do, why, and where. You can use it as a reminder for yourself or a reminder for your colleagues. You can use it interactively during package development or programmatically to check, and you can customize it. And if this got you curious, you can install it from CRAN and take a look at the code and documentation on the GitHub page of Mango the Cat. So that's it. Thank you.
Okay, thanks, Hannah, for the talk. It was a quite interesting package. I think maybe we will include it in the package I will go to present now, because it fits quite nicely. I'm Jakob Richter. I'm from the Technical University in Dortmund. And I'm going to present you the package RT, which stands for R Tools for the command line. And in our daily routine, we want to keep things short, fast, and effective. So, and in other words, we are lazy, right? So for many of us, it means working on the console instead of using the mouse and having this troublesome work. So, but doesn't working on the console mean that you have to type a lot? Well, not actually. If you're lazy enough, then you use the console to automate things. Right, and this is the reason we developed RT. So often recurring tasks should be quick and simple. Working with R, you face many recurring tasks. For example, you want to knit a markdown or a text file often over and over again, or you quickly want to run a Shiny app. Installing packages and keeping them up to date is also an issue, especially if you work on many machines. If you're a package developer, you will run tests, checks over and over. Then also, we have tasks that are quite easy, but we are too lazy to remember them, and especially too lazy to do them, like spell checking your package or uploading it to WinBuilder or RHub for additional checks. So to make all of this easier and more accessible, it should not be hidden behind a GUI or in a function in some R package which name you can't remember or the syntax you can't remember. So therefore, we bundled all of this functionality in one R package and exposed each function in an executable for Windows, Linux, and OS X. So here you see these executables. So, and we did this with a great R package doc-opt, which allows you to do exactly that. So, and how to set up everything is explained in easy steps on our website. So, first installing packages. You might say that's already pretty easy. Well, installing a package and running it in an R session might interfere with already loaded packages, and RStudio will ask you to restart the R session. So why not installing the package in a fresh R session from the beginning, right? So also, installing packages from GitHub, GitLab, and other sources, even local, everything needs another command. So you don't have to worry any longer with RT, we will take care of that. You just have to type R install into your console or shell, followed by the package name or location, and it will be installed. So the syntax is pretty easy and yeah, kind of self-explanatory, because you might have already seen it in the remotes package. You will see it also in later examples. So this directly brings us to knitting. Here you would have to remember different commands depending on the type, the file type. If you're in RStudio, you can just click the button, but yeah, do you always want to start RStudio just to knit a file? That's probably not the case. So back to packages. So installing is one thing. Maintaining your installed packages is another topic. We give you the possibility to list all of your dearly needed packages in one file. In this file, you can specify all sorts of package sources, exactly like with R install. So here you see some examples. So you see CRAN packages, GitHub packages, or random Git repositories. Also bioconductor packages. So why is it so great? So if you have multiple R installations at work, on your laptop, or on a server, then you can sync this configuration file across different computers using Dropbox or Symla. Or you can just share this file with your colleagues, and then with a single command, R update, all the packages will be installed or updated. Which brings us to the next feature. Running R update, you will install all packages or update the ones that are in the configuration file, even non-CRAN packages. So, and here we again use the update package function from remotes, but we combine it with the update package function from R for the best speed. And the best thing is we can also detect if the R version has changed and a rebuild is necessary. This way you won't have to struggle with missing or failing packages after you updated your R version. So finally, I want to show you some of the highlights for our developers. My most often function is rtest. It's perfect because it supports filtering on a subset of tests and can nicely run in the background. Most functions are self-explanatory, but I want to highlight our hub and our Win build can automatically temporarily change the maintainer to yourself. This way you can easily check packages that are not yours, which is great if you work in a team and don't want to annoy the maintainer with random emails coming from WinBuilder or our hub. So finally, I want to thank Michael Lang, who started this small project, and Dirk Zumann, who helped a lot getting the stuff to run under Windows. And yeah, you can find all the details on our project page. And yeah, thanks for your attention.